Hi, my name is Gabriel Byczynski. I'm a master's student in brain imaging and cognitive neuroscience at the University of Birmingham, and I'm here to tell you about a superpower that you definitely didn't know you had. When you're in class and the teacher is trying to get your attention, it can sometimes be hard to hear them. Oftentimes you'll think, I need to look at them to see what they're saying, because just hearing with all the noise around you is a little too difficult. This is part of that superpower I'm talking about, the ability for you to hear with your eyes. So how do we hear and see in the first place, and why does it matter? Well, we hear and see with our eyes and ears. As you probably know, when you look with your eyes, you're taking in all sorts of information around you, the colors of things, the shapes of things, where things are, and what's moving. And with your ears, you do sort of the same thing. You can tell where things are based on how loud or soft they are, and you can tell how big things are by how loud they might be. These are important things that we've grown up with and through past history and evolution have been important in understanding our surroundings and survival, of course. Dinosaurs, after all, were quite big, and so they must have had massive hearing. So what do I mean by superpower, and what do I mean by hearing with our eyes? Well, as I mentioned, pretend you're in a really busy class, making lots of noise around you. Everybody's talking and singing and probably dancing. I mean, everybody loves school, right? But it's hard to hear, and especially when the teacher's trying to get your attention, she may do something like a very common one. The reason this works, of course, is because it's louder than everything around them. But it doesn't hurt to watch either, to look at her hands and to see when they're hitting and in what rhythm pattern. You may not realize that you're also doing this when she speaks. When you stare at her mouth, for example, you can see that she's mouthing words, and with the little bits of sound that you're getting through, you're able to form the full sentence. She may be telling you to pull out your books or pull out a blue pencil, and you're able to tell blue from red based on the b and r sound that she makes with her mouth. Even if you can't hear me, for example, you may have been able to understand that I said blue, red, and yellow without any sound. Just like you're also able to say blue, red, and yellow without seeing my mouth. But when we combine those two senses, as you're doing right now, watching what I'm saying and listening to what I'm saying, it gives you a better understanding of the information I'm trying to convey. So how can we look at this, and how did we even discover this? Well, there was a very famous experiment called the mcgurk effect. McGurk is somebody's name. And with the mcgurk effect, they looked at when somebody says something, how the shape of their mouth affects what you hear. This was done by saying the same sound over and over again. It depends on which experiment you're looking at, but sometimes it was va or da or ga. In this case, we're going to use va. And with the sound va, they changed the shape of the mouth, but kept the same sound playing. Let's have a look at it, shall we, and see if it works on you. Va, va. 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 That was pretty cool, right? You were looking at my mouth, and based on the va, ga, and da sounds, you were able to hear different things. But as I said, the sound wasn't changing. I was still there in the background going va, va. However, it was the shape of my mouth that was changing. This is what we call audio-visual integration, which is just a really fancy term for audio, meaning hearing, and visual, meaning seeing. Integration, meaning that the two things are combined and information are taken from each. So why is this important? Well, we've already talked about it. This is why we are able to hear when people are talking in class, even if you can't really make out what they're saying. Think of a time when you were listening to some music and somebody started talking to you at the same time. You may find that if you're not looking at that person, it's very difficult to hear what they're saying. This is the same principle. We take the auditory or sound information and we can combine it with what we're seeing to give us a better picture. At the University of Birmingham, where I do my research, we're looking at exactly this phenomenon. But the more specifics of it is that we want to know where in the brain that it's happening. It could be happening here, or way at the back. but there are lots of different brain regions, parts of the brain, that could be involved in this combination of information. A little pop quiz for you. What was the name of the researcher that I said that studied audiovisual integration? Last name, McGurk, for the McGurk effect. And a little question for you, if you're able to guess. Where is auditory and visual information, that is, hearing and seeing, often found in the brain? I'll give you a few seconds to guess. Visual information, that is, things going in through your eyes, what you see, goes right to the back of your head, right at the back. Whereas auditory information goes through your ears to the temporal lobes, that is, just above your temples on the sides of your head. These two regions are quite far apart, but there are other regions in the brain that help to combine those two pieces of information, and that's what my research hopes to do. Figure out where in the brain it's happening, and how exactly the brain knows what it's seeing and what it's hearing are the same.